Okay, let's do some homework problems. So in this one, it is asking us to figure out what is the y-intercept, and then here you have the equations for the same graph. So you need to match which one will go with this one. So the idea is we will be using the fact that for y-intercept x is always 0. Why? Because this is your y-axis, and for your y-axis, look how for all of them here x is 0, so for all of them your x is 0. So this is a fact that we will be using. So first we find out what is this point. This is the y-intercept. For that, find out what is this point, find out all these points, which you can do. So and for all of them, so let's do this one. Okay, then so for x it will always have 0 value. For y we need to find out. So 1 2 3 4 5 6 7, and is negative, so -7. So same thing, you will be finding out these y intercepts for these. So find out all these points that the graph is cutting through on the y-axis. So first you find that out. Now how will you match is that you will be plugging 0 for x. So when you plug in 0 for x, this whole thing becomes 0, this becomes 0. So your function value when x is 0 is -1. So this one is your 0, take away 1. Now find out which one of them has 0, -1 y-intercept, and this is how you will be matching. So you can see number 5, this is -1, so 0, -1. And this one, when you plug in 0 for x's, you get -1, so 0, -1. These two are matching. So this is how you match the rest of them. Okay, so this is how you will be doing 1 to 6. Now 7 to 12, here you are finding out what is the constant that is missing here. So you again make your area model and find out. So you will be making this. So here you will be splitting it. So this 6x, you split it into 2. So one of the half goes here, the other goes here. So 3 of them will be going here and 3 of them will be going here. This is your x plus 3. This is your x plus 3. So 3 times 3, 9, and you can see there are 9 of them. Okay, so you will be needing 9 here, but you cannot just add 9 like that. So you will be saying plus 9 and take away 9. So this will look like x square plus 6x plus 9 and take away 9. Okay, and then you will be writing this as x plus 3 and square of that. So it will be x plus 3 and square of that, and then this is extra, so take away 9. So this is your vertex form. Okay, let's do number 12. Okay, if we need to make it a perfect square, the number that we are missing here, we need to find that out. Now there are 5 of them. Okay, now you will be splitting them into 5. So x is, so this will be 1 x squared will be going in each. If you divide this by 5, so you will get 2x. That means each one will get 2 of the x's. So 1 will go here and 1 will go here. Okay, this is your x squared if this is x, and this will be 1, so x plus 1, so 1 times 1 is 1. So this is your 1 here. Same thing you will do for all of them. So you will have 5 of the x plus 1's, okay, and then you will have x squared, then you have 2x, and then you have 1. This is for this one only, but you have 5 of those, so you will do times 5. Okay, if you multiply 5 inside, you'll get 5x squared, 5 times 2, so 10x, and then 5. So basically the number that's missing here is 5. You will be needing 5, but you cannot put 5 just like that. You have to take away also. So then this will become, you can also rewrite it as 5 and then x plus 1 and square of that. You have this take away 5 extra. So this is your vertex form. The vertex is -1 and -5, and its stretch factor is 5. So this is how you will do 7 to 12. And then here it is asking, this is again exactly same thing that we did here. Here there's nothing missing, it's just that how we did these problems, this is exactly like these problems. So you can do those. Here you have f of x and g of x, two different functions. If it is asking when x is 1, what is the function value of the function f? So you just plug 1 here for x and calculate. If it is asking g of x when x is -5, so you plug in -5 for x in the function gx. Okay, so you will be doing 1 to 23, and we'll talk about it tomorrow.